echelon form, E-C-H-E-L-O-N, echelon form. I will not give any definition of this, but you just listen to me carefully, which we already discussed. Echelon form of a matrix. For echelon form of a matrix, if you see a matrix B, I go with some kind of elementary row operations. I go to matrix A, or maybe A, I can do some kind of elementary row operations and get a matrix B. Okay. Whatever, finally the matrix, if I try to obtain or put it in the form of echelon form, means that the matrix A has to have every row in which the first non-zero element will always be 1. Okay. And after that, any other subsequent rows below that 1 in the previous row, all the elements have to be zeros. Okay, which gives me some kind of, it looks to be a triangular matrix if at all is a square matrix. Okay, but if it is not a square matrix, some m by n matrix, this particular definition of echelon form always holds good. Or maybe if you want to write, maybe take some 2-point statement. A matrix A is said to be, in row reduced echelon form. Matrix A is said to be in row reduced echelon form if, first point, the first non-zero entry in each row is 1. Second point, if the column contains the first non-zero entry of any row, then every other entry in that column is 0. Then every other entry in that column is 0. Third point, the zero rows occur below the non-zero rows. Next, take a statement. Rank of a matrix A. Is the number of non-zero rows in its row reduced echelon form. Okay. Sometimes there are certain simple questions in the matrices. Directly a question can be find the rank of a matrix also. Take a question which was given previously. Determine rank of the matrix. A equal to, it's a 4 by 4 matrix. 1, 2, -1, 0, -1, 3, 0, -4, 2, 1, 3, -2, 1, 1, 1, -1. Okay. Now the question is, we have just now defined that the rank of a matrix is number of non-zero rows in its row reduced echelon form. In fact, those non-zero rows is exactly equal to the number of linearly independent rows also, which we have already discussed previously. Okay. Anyway, for this definition, we need to have the number of non-zero rows. To be frank with you, earlier which I mentioned that the column rank is equal to row rank. The number of linearly independent columns equal to number of linearly independent rows. It's a number only. It's a count. It's a count. Okay. Exactly, that's the reason why we have said rank of a matrix equal, row rank of a matrix equal to column rank of a matrix. Okay. Anyway, as of now, you can even go with columns also, number of linearly independent columns or number of non-zero columns in its column reduced echelon form, you can say that way, or number of non-zero rows in its row reduced echelon form. Both of them are same when it comes to that quantity, the number would be same. Though the vectors are different. Because the row or dimension might be different from column dimension. The n tuples of row might be different from n tuples of column. But still, linearly independent rows equal to linearly independent columns in a given matrix. Okay. Anyway, so to find this one, obviously we are going to go with row operations. Row 2 is row 2 plus row 1, properly an elementary row operation, and then row 3 is row 3 minus 2 times of row 1, and row 4 is row 4 minus row 1, which gives me another matrix which is an equivalent matrix, row equivalent matrix, right, which would be a row equivalent matrix. Anyway, 1, 2, minus 1, 0, addition, minus 1, minus 4, minus 2 times, minus 2 times, minus 2 times, and then minus 1 times 2 minus 1, minus 1. Okay. So what you can do here is, you can go with interchange of row 2 and row 4. Row 2 and row 4 can be interchanged. So this is symbolic notation, but anyway, you can write like row 2 and row 4 interchange to get into echelon form. And you can multiply with minus 1 also. 1, 2, minus 1, 0, 0, 1, minus 2, 1, 0, minus 3, 5, minus 2, 0, 5, minus 1, minus 4. Row operations again, 1, 2, minus 1, 0, 0, 1, minus 2, 1, 3 times. So R3 is R3 plus 3 times of R2. R4 is R4 minus 5 times of R2. So 3 times 0, 3 times minus 1, 3 times 1. Minus 5 times 0, minus 5 times is 9, minus 5 times minus 9, which gives me 1, 2, minus 1, 0, 0, 1, minus 2, 1, 0, 0, 1, 0, 0, 0, 0, 0. Okay. Rank of A equal to number of, here you can write, is the row reduced echelon form of A. Row reduced echelon form of A. Therefore, rank of A equal to number of non-zero rows in its row reduced echelon form, which is equal to 3, which is equal to 3. Note, oh, 1 comma minus 1, right? 1 comma minus 1. Note, find the rank of the above matrix. Take a note. In note, I have a question again. Find the rank of above matrix by reducing it into normal form are also called as canonical form. By reducing it into normal form are also called as canonical form. What is this normal form or canonical form all about? Normal form looks in the form of, it can be just an identity matrix IR, order R, or it can be an identity matrix with 0, or identity matrix 0, or identity matrix 0, 0, 0 is called normal form. I'll give different examples. Suppose I have a 2 by 2 square matrix, some matrix A which is a 2 by 2 square matrix. After row reductions, it came out to be 1, 0, 0, 0. Sorry, 1, 0, 0, 1. It came out to 1, 0, 0, 1, suppose. So, the number of non-zero rows equal to 2, number of non-zero rows equal to, therefore, rank of the matrix equal to 2. This is one normal form. We call it as I2. Identity matrix 2 with order of the matrix equal to 2. Or else, we have a different type of matrix. Suppose it's a 2 by 3 matrix. A is given to be a 2 by 3 matrix. 2 rows, 3 columns. Row reduction has given me 1, 0, 0, 1. It's a 2 by 3 matrix. I got 0, 0 here. Okay. This is I2, 0. I2, 0. Identity matrix with 0 column vector there. Or I can have 1, 0, 0, 1, 0, 0. It's a 3 by 2 matrix in which I can write it as I2, 0 like this. Or suppose it is a 3 by 3 matrix or a 4 by 4 matrix in which I got 1, 0, 0, 0, 1, 0, 0, 0, 0. Suppose it's a 3 by 3 matrix. What I got is something like this, which looks like I2, 0, 0, 0, normal. From which the rank of the matrix is exactly equal to the 2 here, IR. R becomes the rank of the matrix. So, in all these normal forms, different varieties of normal forms for different order of a matrix and different rank of a matrix. Different rank of a matrix. Now, R gives me the rank of such a matrix when you reduce into normal form or canonical form. Are you getting that? Suppose if it is a 3 by 3 matrix and the rank of the matrix equal to 3, 3 by 3 matrix and the rank of matrix equal to 3, I should have got it as 1 here, which looks in the form of I3. Which looks in the form of I3. Okay. So, all these things with row reductions. All these things with row reduction. And the normal form or canonical form comes after you got echelon form. After the echelon form is reached, further processing of that, further row reduction gives us normal form or canonical form. So, from here itself, I can use row reductions or row elementary operations to reduce this into any of these canonical or normal forms. Okay. Now, let us do that exercise as well. So, to reduce this into normal form, what I will do is, I will go with some row operations. So, what I have to do, since it is rank equal to 3, so here I should get I3, 0, 0, 0, 0, all zeros here. This should be I3. Okay. Now, what I will do is, first I will try to make ఇది 0 ఎట్లా వస్తుంది? to make it as 0? ఇది 0 ఎట్లా చేయొచ్చు? ఈ రెండు యాడ్ చేస్తే 0 అవుతుంది. బట్ తర్వాత చెప్పండి. రో ఆపరేషన్స్తోనే చేయొచ్చు. Column operations could elementary operations. You can use column operations also. If it has to be only row reduced to normal form, itla kudardu. Square matrix ki kudurtundi. Or else you should have number of rows more than number of columns. Then only you can have row reduced to normal form. Alagala. Suppose if I have to make, I will take this as the reference row now. So I can make this element as 0. But this element cannot be made equal to 0 by using row operations because you don't have any other element in that column to make it as 0. Okay. So quite obviously, unless I use column operations, I cannot make these things as zeros because the row rank I got is equal to 3. If I have to convert this into normal form, this has to and this has to also become equal to zeros, which is possible only if I use column operations. So in order to reduce into normal form or canonical form, if it is a square matrix, okay, it's feasible. If it is non-square matrix, then if the number of rows greater than or equal to columns, then with row operations I can convert into normal form. If not, I have to use column operations. Okay, I have to use column operations. Of course, even for a square matrix also, if you see, this is a square matrix. This is a square matrix. But still, only up till here, non-zero rows only I can convert into identity. What about the rest of the things? It's again a problem. Okay. So what I will do is, I will go with column operations, elementary column operations, elementary column operations. Okay. Then what I get is, so I will again take this as, which one I will take a reference row? This I will take it as reference row and try to convert this into zeros. Okay. Antena chesedi? చెప్పండి ఏం చేద్దాం. C2 is C2 minus 2 times of C1. C3 is C3 plus C1, which makes these elements as zeros and zeros. This is not required to make it as 0. And the last we do the rest of the things. So just check it out. What happens? 1, 0, 0, 0. C2 is C2 minus 2 times 0. C2 is C2 minus 2 times. And then C3 is C3 plus C1. Therefore 0. C3 plus C1 minus 2. 1, 0. 0, 1, minus 1, 0. Okay. Next stage, I will convert these two as zeros. C3 is C3 plus 2 times of C2. C4 is C4 minus C2. 1, 0, 0, 0. 0, 1, 0, 0. 2 times 0, 0, 1, 0, 0, 0, oh, 1 second, this minus this minus this, minus 1, 0. Lastly, C4 is C4 plus C3, which gives me 1, 0, 0, 0, 0, 0, 0, 1, 0, 0, 0, 1, 0, 0, 0, 0. So it's as good as row operations only, but only thing is, instead of first row, we take first column as a reference row in the first operations. Second level, second column becomes reference column. Third level, third column becomes reference column. This came out to be equal to I3 0 0 0. Okay. Therefore, so just mention is the normal form of A. Therefore, rank of A equal to 3. So once you convert into normal form, it directly gives us what is the rank of the